Hi, everyone. My name is Raquel with adtmag.com, and I'd like to thank you all for joining us. The topic of today's webcast is Solving the Hidden Costs of Kubernetes with Observability, sponsored by Lightstep. Before we begin, I'd like to cover a few housekeeping details. There will be a Q&A session towards the end of today's presentation, so please type any questions that you may have in the Q&A box. Lightstep has provided a resource that corresponds with today's presentation, so please take a moment to check that out. And additionally, this webcast is being recorded, so keep an eye out for a link in your email to rewatch the presentation or share it with a colleague. And now I'd like to introduce you to our speaker. Today we will hear from Daniel Spoonhauer, aka Spoons, who is the CTO and co-founder of Lightstep. So we're in great hands today, and with that, I'll pass the time over to Spoons to get us started.
Great, thanks, and thanks everyone for joining today. I'm going to be talking about solving for the hidden costs of Kubernetes. But before I start, just a little bit more about me. My name is Spoons. I'm the CTO and co-founder at Lightstep. Lightstep is a unified observability platform. So whether you're responding to an incident at 3 in the morning or just trying to figure out if you've broken anything with your latest deployment, Lightstep can provide the insights that you need to understand what's happening and get back to building new features or just get back to sleep. Before I helped found Lightstep, I was an engineer at Google. I worked on Google's infrastructure team, helping build technology that was then used by other folks at Google to build the kinds of things that many of you probably use day to day. And I also worked pretty closely with SRE teams at Google to help put practices and process in place to take advantage of the technology. I also wrote a book on distributed tracing, which you can find at O'Reilly's site or wherever else you find books. This covers a wide range of topics on distributed tracing, whether you're just learning about it for the first time. So we'll describe what it is and how you can get started with it, or if you're thinking about building it yourself or deploying a solution, thinking about some of the costs associated with it, and then even kind of going through some specific use cases about how you can leverage distributed tracing and other kinds of telemetry data, and a little bit about where the future of distributed tracing might be as well. So check that out. You can also find me at SaveSpoons on Twitter. So, I don't want anyone to get the idea that I'm down on Kubernetes from the title. I think Kubernetes is a great tool. We've been using Kubernetes in production at Lightstep for years now. I think it's a great way to really enable engineers to move more quickly, and it provides a really great set of abstractions for doing that. What is Kubernetes? Well, like I said, it's a set of abstractions for deploying, scaling, and running services. It's often used in cases where you're running microservices, but anytime you really want to run a bunch of different kinds of processes, whether those are serving online requests or doing batch processing, it can be a great way to do it. It's really part of a longer story. Maybe years ago, if you were scaling up a new service, that would mean, heading down to the server room and racking some new servers. We moved on from there to virtualized environments where we could get a little bit more consistency, a little more easily. And from there to things like containers. Each step along the way here, really, we were trading off some sort of scope and functionality. Each of those got a little bit narrower in terms of functionality that offered. But that, gave us some convenience in terms of, maybe the speed that we could deploy things or, the kind of additional functionality that could be layered on top. And Kubernetes is really part of that, whether that's something like lifecycle management, restarting tasks, handling task failure, things around scaling, and of course, things related to network management as well, how services communicate with each other and how they communicate with things outside of your system. All of that convenience, though, comes at some price, not only in terms of how you narrow things, but also in terms of the functionality that's offered, but also just there's other costs associated with Kubernetes, which is what we're going to talk about today. So, first of all, Kubernetes doesn't magically make infrastructure easier to manage. I think, the best way to think about it in some sense is that it allows you to isolate a lot of that infrastructure management, so that, a small number of folks at your organization, maybe your platform team, can think more about that. And that frees maybe service owners to worry about less of those details. It also, can make it harder to understand performance changes. So, when you do a deployment, did that increase latency? Did it change resource consumption in some way? Or even did it fix a problem that you were trying to fix in that deployment? Kubernetes can also make it harder to aggregate telemetry data, whether that's logs or metrics or something like traces. There's, sort of more moving pieces. In some ways, there's the services themselves are by design sort of a little more isolated from the infrastructure, so that can create some problems. And even if we had all of that data, even if Kubernetes was helping us store it and manage it, it still doesn't necessarily help us answer questions and about what's happening. And in a lot of ways, it's actually making those problems harder. So traditional monitoring is going to come up even maybe more short than it would in other situations. And all of this, at some level, it shouldn't be super surprising. There's sort of a natural feedback loop in lots of different systems, whether it's software or not, where you have these two kind of complementary processes. On one hand, you have control. That is, there's some actions that you can take to affect the system in some way. In Kubernetes, that might be, doing things like deploying a new pod or other taking changes to an ingress. And then on the other side, you can observe what happens, right? And these two things are, of course, tightly interrelated. Obviously, when you make changes, that'll mean there's different things that you can observe. And as you observe things, you can gather more data about what's happening and use that to affect, to make different choices about what you want to change in the future. And Kubernetes, it sort of by design is really only, solving one half of that equation. It's really only meant to be, it's an orchestration mechanism, right? It gives you that kind of control. And so, as you're thinking about starting to deploy, or maybe you're already deploying Kubernetes, thinking about how you're going to complement that with something that will allow you to better understand what's happening. That's particularly important in the kinds of systems that folks might be building on top of Kubernetes. So if you think about your system as sort of this interrelated set of services and ingresses and things like that, Kubernetes gives each team more control of those things, but now control is more distributed, right? Each team has control of their own service. They decide when to push new code. They decide when to make configuration changes. But each team also depends on many other services, right? So that might be, other microservices or other, storage systems, things like that. It could be the infrastructure itself that also they depend on in some way. And it could be other managed services. They might not be even something that your organization owns. It might be, a hosted storage system. It might be some sort of, third-party fraud detection or sort of other outsourced AI that you're doing. And the real crux of it is that, an individual team, maybe you and your team, you only really control one piece of this whole system, but you're responsible for the performance of many of those things, everything that's below you in the stack. This is sort of the textbook definition of stress, right? Is that there's this gap between what you can control and what you're responsible for. And this is, I think, kind of underlies a bunch of the different sorts of costs that we're going to talk about today, is this sort of separation and sort of thinking about the trade-off here as we distribute control across our organization. How do we make sure that we can still hold the right folks responsible for changes that they make and make sure that we can do that in a cost-effective and efficient way? So let's kind of talk about those the costs and how they kind of relate to that stress. I'm going to walk through three sort of different kinds of costs that you might, in fact, probably will experience if you're running Kubernetes, even if you haven't already. So the first category is around monitoring costs. So, things like logs are maybe never cheap, and the complexity that something like Kubernetes adds will just magnify that cost in a lot of ways. So in particular, if you're thinking around something like metrics and cardinality, as the complexity of your application increases, that cardinality is going to increase also, right? Cardinality is sort of the measure of how many metrics you have, not just in terms of, you're measuring, say, latency and error rate, but also in terms of the number of tags and the values of those tags that you've added along to those metrics. So that might be per host or per pod, things like that in the Kubernetes environment. Of course, as your application scales, there's going to be more logs and things like that as well. And usually when those costs goes up, it starts a discussion, maybe between you and your boss or your boss's boss, like, what's the value that we're really getting from this vendor? Should we really think harder about that? And maybe, part of that is going to be, should we deploy our own metrics solution, our own log aggregation solution? Or maybe we should just be monitoring less, right? Maybe we, turn down logging in the QA or the staging environment because it's expensive, and maybe we see a little bit less value in that. But, we'll talk a bit more about some of the costs around, deploying your own version of these things. But obviously there's costs to just monitoring less too, right? Because it makes identifying root causes harder. It's going to extend the time that you need to spend addressing an incident. And I think in all these things, as your application grows, as your organization grows, all these things are going to get worse. The second kind of category of costs is around understanding dependencies. One of the things that Kubernetes does is it makes it really easy to add new services, makes it easy to call external APIs. And, the cost of services has always been pretty high. Even years ago, Martin Fowler was saying that there's a sort of premium associated with microservices, and that even if you think you're going to need microservices someday, you should really start from a monolith and of course, do that in a modular way. But try to take advantage of all the good things that a monolith gives you early on in the sort of in the life of your application. Kelsey Hightower has been arguing a bunch for monoliths lately, that there's a lot of advantages to them. And certainly, I think there was a post not that long ago from a bunch of engineers at Google talking about how they're sort of stepping back from microservices and moving towards macro services. They decided that 1,000 or whatever 1,000 microservices was maybe too many for their organization. And kind of one of the big kind of costs here, the premium, if you will, is that as you split things apart, it takes more time to understand who's to blame, right? So there's more time kind of figuring out, building your own understanding of it, and then communicating that understanding with someone else who might have come to a different conclusion. And, part of that's like, the goal here of something like microservices is to let teams move more independently, but that's, of course, a double-edged sword, right? Understanding how they're all moving is going to be more difficult. And then finally, the kind of third area of cost is that, this abstraction doesn't come for free. Someone has to know, like I mentioned, someone probably in your platform team has to understand, how to deploy Kubernetes, how to upgrade, when to upgrade, how to run storage and other infrastructure on top of that. That's not an easy thing. And, as you're building your application, there's also some expertise required in making sure that you're building an application in a way that's resilient to those kinds of changes, right? When you do a node upgrade, have you deployed your services in a way that will make sure that they still run without interruption? And, there's always risks around, the number of people that understand these details, what happens when they decide to move on from the company. And I think probably you all too have been in situations where you've accumulated a bunch of this debt, and then there's a question that just has to be answered where, when do we start over? When do we sort of cut the knot and decide that, we've started building up new expertise? And certainly, any tool is going to come with this, and so it should be sort of a cost that's weighed as you're thinking about that adoption. So, maybe not super surprisingly, given, where I've been and how I thought about this, that observability, I think, is a big part of the solution here. Like I said, I think, containerization, Kubernetes, a lot of the associated tools that folks have built up in that ecosystem around Kubernetes, whether it's, configuration tools like Helm or RPC mechanisms like gRPC, There's a lot of great tools out there. Again, these are all really part of the control side of the equation. And if you don't understand what's happening, then those tools are going to be a lot less effective. So observability, I think, is a really key part. And I think where a lot of organizations sort of think about observability as a kind of an afterthought, unfortunately. They start around that circle and sort of wait till they're halfway to start deploying some kind of observability solution, and I think that's often too late. Maybe I should just say what is observability. Observability is really it's an approach in a lot of ways. It's not a single tool that you can buy or anything like that. Of course, there's a lot of tools that can support observability, but really it's a process and a practice of understanding your system, about being able to understand why things are happening. And maybe, more concretely, how do you know if you have an observability, Well, if you do, then it's easy to navigate from effect to cause, right? So it's not merely that you know that something is going wrong, but that you're able to quickly understand what the cause of that problem is, and then hopefully able to mitigate and address that in some way. One of the questions that comes up a lot is, how does observability differ from monitoring? There's a lot of definitions of both of these things kind of flying around. I think I'm kind of pulling from the new stack a little bit here, that monitoring really focuses on defining normal. And then, if you're doing monitoring well, then when you've deviated from that, right? When your application, when your system has changed in some way, and you're able to recognize that change quickly. And that's great. I mean, you should be able to do that, but I think observability takes it one step farther and makes sure and lets you not only just know when you've deviated, but help to understand why that's the case. Part of that is really being able to understand the huge set of signals that are going on. Like, this is not a signal to noise ratio problem. It's more that there's just too much signal. Because in a microservice application built on Kubernetes and a bunch of other infrastructure, there's thousands of things that could be going wrong at any moment in time. But there probably are lots that are going wrong at any moment in time, right? But the question that you really should be thinking about is which of those things that are breaking are actually impacting your users. And those are the ones that you need to be addressing. So, there's a lot of different ways to think about that. And these are all sort of things that come into play from a monitoring point of view, right? Like having logs, having metrics, having traces, being able to look at some of the underlying infrastructure metrics, whether that's things coming from the kubelet itself, or being able to break down resource consumption for your application on a basis of container, pod, namespace, and so on. Understanding things like resource utilization. Those are all really important in a lot of ways. And being able to connect which one of those are actually relevant is pretty important. And observability is the thing that's going to help you answer those questions, right? It's providing this comprehensive, a holistic understanding of your system, not just individual pieces. So it's really bringing back together, these pieces that you've separated. Like, you've enabled these teams to work more independently. You've given them that distributed control. Observability kind of brings it back together to give you and everyone else in your organization a clearer view of the big picture. Like I said, of course, there's tools involved, but there's absolutely cultural and process changes and different ways of thinking about the data involved there in order to do that. It's not just a new tool or a new dashboard. I think there's a lot of risk to thinking about dashboards as kind of the solution. Like, I've rolled out a new service, I've got a new dashboard, I'm done. Really, when you've rolled out a new service, you've created a new set of interactions. You've just, you've not added to the things that could go wrong. You've multiplied it, right? And so, one dashboard is probably not enough. So I want to kind of dig in a little bit more and talk about, just kind of as an example, think about how we might quantify some of those costs. So this is all, sort of manufactured in a way, but meant to give a sense of how you could kind of carry out a similar exercise for your team and for your organization. So there's sort of two primary costs that that are sort of associated with, I think, how folks think about monitoring systems, and likewise how you can think about observability. And really, I mean, these are sort of generic in a lot of ways. So on one side, there's what I'm going to call capital costs, and that's really for the collection and storage of the data, of the telemetry itself. And on the other side are the operational costs, the OpEx, which is really what's required to understand and derive some value from that. So I'm kind of going back, I mean, probably some finance person is going to shake their head at me, but the CapEx I really think of as like, what are the raw materials and how do we acquire them? In this case, the quote unquote raw material is the data that we need. If we don't have the logs and the metrics and the traces, then, we can't start really. And then the operational cost, the OpEx, is how do we take that raw material and then derive some business value from it, right? And that's where we kind of transform the data into these insights that we can then use. So on the capital costs, on the CapEx, so again, just kind of as an example, assume we're going to go some sort of open source route. So say we're going to deploy something like an elk stack. So, just to take logs, we're going to have to pay for some storage and compute and network to aggregate and then, build the indexes so that we can actually find those things later. And we're going to have to think about, how many instances are we going to need at sort of peak traffic? How long do we want to store that data? And how many services are involved in an individual request? These are all kind of factors that go in. And just to kind of sketch out what this could look like for sort of a medium-sized organization, I think we kind of throwing these numbers together, we're thinking about an organization of, say, around 50 or 60 engineers, and made sort of assumption that you're generating about 50 gigabytes of log data a day. That 14 days is enough for you to maybe understand, say, week over week changes in that. Look for, give you enough time to discover things that went wrong that maybe weren't so obvious in the moment. And just to kind of simplify things, we're assuming that all of those logs are going to be needed to be highly available, so we're not going to leverage any cold storage. So kind of going through this, our kind of back of the envelope said that we'll need one compute optimized instance for the master, 2 memory optimized instances for the data, and then a few SSDs to actually store the data. And kind of like playing this all out, then we get to monthly cloud spend of about $716, which is really not so bad in a lot of ways. That's not such a huge price tag given kind of the size of the system and organization that we're talking about. But, these systems don't install themselves, right? Like Elasticsearch, Kibana, like they don't upgrade or patch themselves, and it'll take engineering time to do that. So really when you factor in kind of the maintenance just to have the data there, it's much closer, we think, to around a little over $3,000. And that's starting to be kind of a fair chunk of change. That's really accounting for the human cost of just having the data there. Now, on the operational side, once we've got the data, we have to think about how do we actually, use that for something. And just to take, there's a lot of different ways that we can use this data, but just to kind of take 2 to get kind of a lower bound on what it might take. We thought about, how much does it cost to employ an engineer? How much time do they work in a given year? And we're really looking at sort of 2 use cases here. One around incident response. How many disruptions is an engineer investigate on average? How long does that take? How many are involved? And then the second use case is really around deployments. And when a deployment's made, that's an exciting moment maybe for a lot of engineers, but that's really the moment when, it can be scary, right? That's when they have to really see whether or not what they wrote worked. And they need to make sure that they didn't, break anything in the process. So, we took kind of just to work through this exercise, we assumed the average annual cost for an engineer is around $200,000. I think this is taken from some survey of Bay Area companies. But when you factor in, things like benefits, health insurance, payroll taxes, actually not so hard to get up to this point. We assume engineers work about a little over 2,000 hours a year, and that comes out to an hourly cost of about $89. Our assumption was that each engineer, there's 10 interruptions that they are involved in, and each one of those is about 4 hours. Again, that might be low or high for your organization, but that's really not that many in a lot of ways. And then, we're assuming that every engineer deploys 50 times a year. Maybe that's a little optimistic, but hopefully you're shooting for something kind of on that scale. And that it takes about 30 minutes to validate what's happening there. So all of that put together means that the cost per disruption is about $3,500. That's assuming that an individual, and teams that I've worked on, it's not just one person responding to an incident. Almost always that other folks get pulled in. Maybe that's not because they're actually responsible for part of the problem, but because someone thought they might be. Doesn't matter. They're still interrupted. They're still not getting other work done. So part of this is about mean time to innocence, in addition to mean time to resolution. And then, the other half of this on the deployment side is actually, it's pretty significant. If you go through and look at what the cost would be, again, for a team of around 50 or 60 engineers, this is, the big piece of an additional engineer just, for folks kind of sitting around clicking refresh on a dashboard to make sure that everything is going okay. So, and that's, a real chunk of change. So, kind of looking together, there's not really a way that we're going to make a big dent in the cloud costs here. Maybe you can negotiate a little bit of a better price for an instance. Maybe you can optimize a little bit, but really, you're talking about a few percent improvements probably in those cases. If you're really going to make a dent in these things, it's going to have to be a much more significant impact. And that's, the thing that you really can control is how long it takes to do these sorts of tasks and how many engineers are involved. And what we've found at Lightstep in working with our customers and talking with other folks in the community is that an effective observability practice that is, as part of a transformation from more traditional monitoring can have a really big impact on these numbers. Potentially even improving them by a factor of 5 or more, and that brings incident response costs down below $1,000. But maybe even more importantly, the time that it takes to validate a deployment can come way down, from more than $130,000 a year down to about $26,000 or $27,000 a year. And that's really just because instead of spending half an hour to see if the deployment was successful, you can do that in 5 minutes or less. And that's, really thinking about the effectiveness and people doing these very, very common and frequent tasks. So how do I do that, right? How do we get there? Well, really this is about holistic observability, and it's about using context as a mechanism to control those costs. So I'll only talk a little bit about that. So that context is generated really in 2 ways. The first one is by improving communication. I think, it's easy for teams to all kind of fall into their own rut around the kinds of metrics, maybe vanity metrics that they're all measuring. And what's important to one team might be different to what's important to another team. And that's a problem because now they can both be right in a sense, which is that they're both, talking about and measuring their own metrics, but maybe they're actually fundamentally disagreeing about whether or not the system overall is working or not. And really, the solution there is to come up with a shared language to discuss things like performance, and through things like service level indicators and service level objectives. If you've read the Google SRE book, you've obviously heard of these, probably heard of them in other places too. And I'm not saying that you need to adopt every practice that Google SRE teams are advocating for, but I think this is one of the most important ones. Just your teams need to be measuring the service that they're providing in a consistent way, and really that service needs to be oriented around their users, right? Whether those are external users or whether they're other folks within your organization. The second part of this is really helping avoid alarm fatigue. Bringing it back to service level objectives, especially if those, like they should be, those SLOs are tied to some business goals. It allows you to sort of say no to a lot of things, right? And to sort of ask and answer questions about, hey, I just got, alerted 3 times about this thing. Is that really valuable? Should we have that alert? And, in my experience is like a lot of times the answer is actually no. Like someone with the best intention added that alert, but it's not, fundamentally about the value that you're providing to your users, and it's a distraction, right? So getting rid of those alerts that you don't need and bringing it back to the SLOs that really matter to your users is important. And having that shared context will help your teams, both set goals and then work more efficiently together. The other kind of context is really about the data itself. So, we talked about logs a bunch, and I talked some about metrics. Along with tracing, these are kind of considered the 3 pillars of observability. But in a lot of ways, and I think this, I'm going to kind of speak to it in this slide, is they're not 3 separate tools. They're not 3 isolated things. They're 3 different ways of describing your one system, right? They're 3 different kinds of data, but they all have the same source. And in fact, they actually can kind of be converted from one to the other, right? So, you could take, an Apache log and you could extract a metric from that, right? About request rate or about error rate. If you have a correlation ID in your logs, you can use that to generate a trace, right? So really, they're not separate and not fundamentally different. They're really just kind of different data structures in a way. And of course, some data structures are better for some kinds of things. But by putting them in context, you can really reduce the search space as a user of these systems, right? So now I can say, I don't want to look at all of the logs. I just want to look at logs from systems that are actually handling the set of requests that I care about, right? Maybe I don't care about all the different metrics that were being collected at this time. I only want to look at the metrics that actually correlate with, say, an increase in latency. So again, there's a huge space of signals. There's a potentially huge set of things that are broken or changing or going wrong at any moment in time. And really cutting back on that search space to allow me as the human user here, as the human operator, to focus on the things that really matter is pretty important. The other way that context can actually help is it can actually inform the actual collection storage processes themselves. In that, if we know that looking at metrics, there has been an increase in latency, we can use that to change the way that we're actually collecting and storing logs. If we're looking at traces, we see something goes wrong, say, low in the stack, we can use that to inform how we're managing traces higher in the stack. Or maybe it's just something as simple as noticing that a deployment is happening and just turning up the volume knob a little bit because, hey, something's changing, and having a better view of what's going on is going to be a lot more valuable right now, rather than just keeping that volume on all the time. So observability really says, rather than 3 tools, thinking about how to provide sort of a single view of what's going on in your application. So, how do I get this? I'm going to wrap up kind of by talking about sort of 3 things that you can kind of take away. So, the first one is making sure that your services are observable. How do you make sure that you're building for observability? The second one is, going back to what I was saying about service level indicators and service level objectives, picking the right ones for you, your organization, and then putting people at the center of that strategy. That's really, I think, key because ultimately, it's the people that are responding to these events. It's the people that are building new software and thinking about how their time is being used and how we can make them more productive in their work. So to start, building observable services, really this is about, I think, starting from open source. It's sort of interesting, I think, where the industry is going in terms of thinking about the creation of telemetry. So, years ago, it was really about, getting the right agent or something like that. But, those agents, that technology has really been commodified in a lot of ways. And one of the great parts about that is that we can now all work together on those things. And so, before you're even thinking about, whether you want to use a vendor or you want to use an open source solution for storing and analyzing this data, definitely, I think you should be using a standard like OpenTelemetry for instrumenting your code. You can find out more about OpenTelemetry at opentelemetry.io. It's part of the Cloud Native Computing Foundation. It sits along things like Kubernetes, like gRPC, and it's really a way to get data out of your application. And as an application and a service owner, it's a way for you to leverage the work of the community and maybe give back to that community as well. OpenTelemetry, there's a Kubernetes operator that will allow you to easily deploy the OpenTelemetry collector. And I would also advocate thinking about things like service meshes. Istio is a great example of that, that are really great way of kind of getting started quickly with observability, because it'll allow you to generate and to create a lot of these different kinds of telemetries pretty quickly and pretty easily without a lot of changes to your application. And then if you do want to make some changes to the code yourself, OpenTelemetry provides a single set of APIs and SDKs to do that in a way that, again, it's going to be portable no matter what other solutions you use, even if you're using a set of solutions to store, process, and analyze that data. The second piece of this is creating the right SLOs. Depending on where the kinds of uses you're thinking about. If you're thinking about e-commerce, then signals around the time it takes to check out or the time it takes to provide recommendations, things like that might be pretty important. If you're doing some sort of streaming service, then maybe throughput's a little more important to you. For a lot of things where there's users involved, my advice is to standardize around the golden signals, things like latency, throughput, and errors, maybe saturation if that's also important too. But really, if you're going to do anything, start with latency, throughput, and errors. That'll get you a long ways towards getting a good understanding of how your application is behaving. And then, defining service level obligations, SLOs. You can think of those as your goals for those signals, right? And it's less about, my health checks succeeded, 99.99% of the time, and more about things, like I wrote here, when people trying to play a song, it plays. When people check out, it succeeds. And the thing that's sort of nice about tying it back to these business goals is that it helps facilitate communication, not only within engineering, but also other parts of your organization, whether that's product, security, even, on the finance side when we're talking about, planning, resource allocation into the future and thinking about how that's going to map back to, the outcomes that we want for our users. And then finally, focusing on the people. This is all about using data and these insights to support workflows, right? This is about what are the folks on your team and on other teams in your organization doing, and how are they doing that effectively. In a lot of ways, Kubernetes increases complexity, right? It's another layer in the stack. It provides an abstraction, and like I said, it can help separate some of the concerns between a service team and a platform team. And, there's risks there. Sometimes you need to see through that level of abstraction to understand what's happening. And observability can really make that accessible to more people, even when they're not experts, right? So making sure that your telemetry has the right kinds of tags around not just pods, but nodes and clusters, namespaces, things that are sort of lower down the stack, can give people high on the stack visibility of what's going on there. Observability also just makes it easy to see the impact of changes that are made by your coworkers, right? So as other teams deploy things in your system, understanding, how the different versions of your dependencies are affecting your service's performance is pretty important, and likewise how they're in turn affecting the performance observed by end users. And then, finally, like any tool, Kubernetes is supposed to be making hard things easier, right? But really, as I said, Kubernetes is about orchestration and it's about the levers of control, and pairing that with a strong observability practice and the right tools will let you see the impact of those changes and make sure that you're not surprised, and make sure that your team doesn't get burned out by that kind of endless set of changes. So that about wraps it up for me. Before I open up for questions, I just wanted to give a quick pitch for Lightstep and say, if you're interested in learning more about what Lightstep can do, there's a free trial that you can get started with today at go.lightstep.com/trial. You can also, of course, read about what our customers are doing with Lightstep and of course, a lot of developer documentation and things like that as well on our website. But yeah, with that, I'd love to open it up for questions.
All right, awesome. Thank you, Spoon. So just a reminder to the audience, if you have any questions, type them in the Q&A box now. So our first question is asking, should microservices be designed as microlists or macro services to balance complexity and operations management?
Yeah, I feel like if we didn't understand exactly what microservices were, now we've added, a handful of more terms to the mix. I think all of this comes back to me, microservices are really about giving teams more independence, right? It all comes back to what value you want to get from these things, right? And so the way that you divide your software, for better or worse, it's often, this is sort of Conway's law, right? It's going to reflect the organizational structure and the communication patterns of the people. And just being aware of that tension, I think is sort of half of the solution. And then I think the other half is again, looking at the practices that your people are going to do, who's responsible for deployments, where does it make sense to have an SLO that you're going to measure and track, and where does it, is it not important to measure that kind of thing? And really being, I think, deliberate about drawing those boundaries, and whether you call them macroservices or microservices, I think, again, thinking about the boundaries of responsibility and who's going to take control are the right way to architect your system.
Okay, wonderful. We have another question here. It's kind of a two-part. So it's asking, what are your thoughts around Rancher and OpenShift for what these platforms provide? And also, what does Lightstep duplicate or add to these environments?
Yeah, great question. So again, in my mind, maybe this is kind of a simple view of the world, but thinking about this kind of split between control and observation, and Rancher and OpenShift and other tools are really, to me, they're more great tools for the control side of things, right? They give you, more tools to affect change, across, whether that's across cloud providers or across regions or whatever you need. But again, that's really just, adding to the tools that allow you to take more actions, right, to coordinate more things, maybe in more sophisticated ways. Like any new tool that you bring on, there's more expertise that you're going to have to think about, more complexity that you're adding to the system. Lightstep really sits on the other side of the equation. So it's not really duplicating anything there. What it's doing is providing a tool that can sort of ingest all of that data, whether it's coming from your application, whether it's coming from things lower in your stack, and putting that all in a place that's really focused around the workflows that are important to your users, right? So again, the two examples that I gave before, thinking about, responding to a page at 3 a.m., being able to quickly identify the root cause and mitigate that, or, understanding whether or not a new deployment has had a significant impact on performance or other changes to your system.
All right, awesome. Well, I think that's all the questions we have for today. Thank you so much, Spoon, for being with us and sharing your expertise. And also a special thank you to the audience for attending today's webcast, sponsored by Lightstep and presented by ADTmag.com. Have a great rest of your day, everyone.